today we have in this session, we have 5 presentations. So first presentation is going to by the Ali Shalbafan from Iran. He is going to talk about the potential of dead palm frond waste for particle board industry. So Ali, you can share your slide.
So, hope you have it. Or
I don't know. If you click something go wrong, you can stop that one. I think you share your. You just first open your PPT. First, you open your PPT, and then you go to the share screen.
the
First,
PPT
you
is
open
already
your
open.
slide. First you open your slide. Then you go to the share it, because now you are sharing. Yeah, minimize. Yeah, right. Now it make it full screen.
Okay, so can I start?
Yes, yes, you can start.
Okay, so hello and to everyone, ladies and gentlemen. Thank you for being here. Today, I would like to present you about the potential of date palm fronds waste for particle board industry. In the beginning, I have to say that recently we did 2 large projects in this topic, and today I will just present you very, very short results due to the time scale. The content of my presentation consists of a very short background about the wood-based panels industries, as well as some highlights about the date palm, especially in Iran. Then I will present you some major objectives and the methodologies used in this study, and finally some of the important and highlighted results and conclusions will also be presented to you. According to the FAO statistics, the production of wood-based panels in the world was drastically increased since the last half a century, and it was increased from around 25 million cubic meters in 1961 to more than 370 million cubic meters in 2020. Which is actually a drastic increase only in half a century. More or less the same trend can also be observed in Iran. The whole wood-based panel production in Iran was about 400,000 cubic meters in 2000, which was also increased to more than 3 million cubic meters in 2020. The main important finding is that the increasing rate was really high only during the recent years. Of course, the major problem for such an increase in the world and even in Iran is the raw wood shortage, and the wood supply makes big competitions between the wood-based panels producer as well as with the bioenergy sector, and this competition led to an extra increase in the wood price, which is of course unacceptable for the actually I'm hearing another voice from somebody else. That would be nice if you mute your microphone. Thank you. And this competition led to an increase in the wood price, which is not acceptable for the wood-based panels manufacturer. Of course, there are several ways to cope with the wood shortage, but one of the most interesting ways, which was recently attracted a lot of interest, is the utilizations of local agriculture residues. As you may know, for example, a company in China was already since some years started to produce particle boards out of wheat straw, which is called Wanhao EcoBoard, and also a company in USA under the brand name of Iurka started to produce MDF from rice straw, and also recently the Wotec in Egypt has commissioned it for building a factory for manufacturing MDF from rice straw as well. The other agricultural residues like bagasse, canola, and etc. has also good potentials for the board production. But in Iran, one of the most available and abundant residues is the date palm frond. Actually, Iran is one of the biggest cultivation area for the date palm, and with the area around 240,000 hectare. And considering the number of tree and also the residues for each tree, we can estimate that nearly 1 million tons of date palm frond is available in Iran, mostly in the south of Iran and southwest of Iran, which is annually available in each year. Currently, there are 3 small-sized factories in Iran who are using of this date palm frond particles, which is called Dept, BAM, Moslehi, Kazur, and 12 Farward in Rafsanjans, who are producing particle board out of date palm frond. But all of these companies have faced with several challenges and problems. I can say a lot of dust and fine particles is generated during the chipping process of the date palm, and also the produced panels have a very high density, more or less more than 800 kilograms per cubic meters, and also the boards have a very low quality surfaces. Due to that, actually within the 2 main projects, we just try to define several objectives, but I can say that the main one was the decreasing of the particle board density using various date palm frond particles, and also trying to improve the surface layer quality of the board. In this study, we just collected the date palm fronds from a local farm in Giroft in the south of Iran, and we just try to evaluate the various particle preparations methods. Actually, we use 4 different chipping method or series. The first one, which we call it CM process, we use a drum chipper and for chipping the date palm frond, and then the particles went through a industrial hammer mill. In the second process, after drum chipper, the particles went through a knife ring flaker, and in the third one, which is called CFM process, after drum chipper and knife ring flaker, the particles went through the hammer mill as well. And in the last one, the date palm fronds were directly passed through the knife ring flaker and then hammer mill method. Of course, 4 different particles were generated, which has a different geometry and sizes, and this analysis of the geometry and sizes were perfectly analyzed by my colleagues, which I will introduce them in the end maybe. And using these 4 types of particles, we will try to produce different particle boards. For the board production, actually, the constant variable were the panel density and panel thickness, with a density of 650 kilograms per cubic meters and 16 millimeter thickness. We also use the press temperature of 170 degrees C. The press factor was 15 seconds per millimeter. We use 12% urea formaldehyde resins for the surface layers and 10% for the core layer. The ratio for the face to core layer was also kept constant in all panel variations to 50 to 50%. The panel compositions were different in terms of the particles used for the panel manufacturing. Actually, the four types of particles generated during the chipping process were used as the core layer particles, and for the surface layers, we use industrial fine wood particles. And in the last series of panels, we just try to mix the coarse cheaper hammer mill particles with the coarse wood particles and also with the fine wood particles for the surface layers. Now I would present you some of the main mechanical and physical properties of these boards. The bending strength and modulus of elasticity is presented here. As we can see that the particle geometry, I can say that had showed no significant influence on the bending properties, both bending strength and modulus of elasticity, and that could be due to the panel compositions, because these type of particles were used in the core layer, and the bending properties is mostly affected by the surface layers. Importantly, the most of the panels except the flaker, knife ring flaker hammer mill particles already passed the standard values of EN 312 class P2, which is for a conventional particle board for interior application. Here we can see the internal bound values of those panels. Actually, the panels produced by drum chipper hammer mill method showed better results compared to the other particles. And also I can say that the panels produced by mixing with wood particles actually showed very good internal bound values, which was already close to the standard values for conventional particle boards. The thickness swellings after 2 and 24 hours water soaking is also presented here. Although the minimum, or although the lowest thickness swellings was observed in panels with Flaker hammer mill method, but the other panels were also showed an acceptable thickness swellings, which is actually needed for interior applications compared to literature values. Now, for the water absorptions, actually, I can say that more or less the same trend was observed for panels like thickness swelling. And although the lowest values was seen in panels produced by Flecker hammer mill, but the other panels will also have a very good water absorption, mostly below 75%, which is more or less according to the values for conventional particle boards compared to the literature review. But I would like to also talk about one of the main challenges which we had during the chipping process, and that was the stacking of the knife ring flaker, which happened during the working typically. And due to that, actually, I would say that using the knife ring flakers for chipping of the 8-pound front would not be a good idea in the industrial scale. Now, considering these results and also some more results which we already received in these two projects, I would present you some of the main conclusions. The particles produced with cheaper hammer mill method had higher thickness and lower slenderness ratio, which is actually good for the board production. The higher content of oversized particles were obtained in Flecker hammer mill method, which is actually unacceptable. And the types of 8-pound particles in the core layer actually did not show significant influence on the bending properties. And the highest internal bond values was observed in panels produced with cheaper hammer mill method. And I would say this is the optimal chipping process for this type of lignocellulosic materials. And all in all, panels with a mixture of industrial wood particles and date palm frond particles showed promising results for further industrializations. Now, as I said, actually, we recently at Tarbiat Modares University in Iran did two main projects regarding the utilizations of date palm under the leadership of Professor Said Kazemi Najafi, and also one of our latest graduate students, Dr. Iqtidar Nejat. So thanks to both of them for their kind help. And also thank you all for being here and for your kind attention. And if you have any questions, I would be happy to answer here, or you can also
Thank you,
directly
Ali,
read
for
to me
giving a
and
very good
my
overview
colleagues.
about the particle boards, and it's really the what you call that the how it can be utilized as a commercials. You can stop your
Yeah,
screen now because it's visible to me.
yeah.
Any question? Let me know that one. If any question is there, otherwise we have the second speaker. Basically, he's on the field. So I will try to present his video, but I'm not sure that how much, because yesterday we have some issue. So I try to share his, if there is no question, we move forward and
So I can
try.
see a questions from Stefan Wenk.
Yeah, there is a one question. Just now somebody typed. Yeah, you can give the answer if you already saw the
Okay,
implement.
yeah, thank you very much for the interesting. How did you see the chances to implement an industrial production based on the availability of the material, which is less than wood? Yeah, it's a good question. Actually, I would say the most farm of the date palm in Iran is localized in the south of Iran. So if you make a industry there, to be sure you would have enough materials for your productions. Of course, we are not talking about making a factory with a production capacity of 2,000 cubic meters per year, but something around 500 cubic meters per year. I can assume that we would have enough materials in this area in Iran. Yeah, another questions. How was the life cycle and wear on the knife and tools using fiber compared to using wood? Actually, we have not yet done the life cycle assessment, but we can actually assume that more or less we would get the same results like wood or even better. But regarding the tool wearing, yeah, that would not be a big deal because, as you may know, the tool technology has been developed quite well in recent decades, actually, and so there are not so much silicium in this type of materials, and according to our discussions with some companies, that would not be a big deal. And as I already explained to you, there are 3 small-sized factories who are using these materials for the board production, and we never heard any, let's say, negative points about these issues.
Okay, Ali, thank you so much that we are moving forward, and later on, if somebody wants, they can